Okay, good morning. Welcome to the first online interactive chemistry class for class 10. Today we'll talk about acid, bases and salts. And about the syllabus, the entire syllabus for acid, bases and salts is intact except for the last portion. If you go to page number 22 in the syllabus section in the front portion of the book, you will see that methods of preparation of normal salts with relevant equations. Method of preparation is excluded, so you do not have to study that much. Okay, so as far as the book is concerned, you do not have to study page number 50, 51, 52 and 53. We have to do the last page, page number 56 we have to do. Okay, so it's there in the syllabus. Methods of preparation you need not study. So let me start with acid, bases and salts. Let me talk about the acid first, okay? So when we talk about acid, we have different types of acid. Mineral acid and organic acid. Okay? Mineral acids are those which are derived from minerals. For example, sulfuric acid, hydrochloric acid, carbonic acid, sulfurous acid, nitric acid, and phosphoric acid, and so many other acids. So these are the important ones that you have to remember. So let us talk about hydrochloric acid first, then nitric acid, then sulfurous acid, this is sulfuric acid, this is phosphoric acid. Okay, so these are mineral acids. And let me tell you what is mineral acid. Mineral acids are those which are derived from minerals, and organic acids are those which are derived from plants and animals. Okay, we will talk about organic acids later on in detail in the last chapter. But for now, organic acids are those acids which are derived from plants and animals, and mineral acids are those which are derived from the minerals. That's all you have to remember. Now, as the name implies, what is an acid? An acid is a compound which, when dissolved in water, produces hydrogen ions as the only positive ion. So let me repeat it. An acid is a compound which, when dissolved in water, yields hydrogen ions or hydronium ions as the only positive ion when dissolved in water. So when we talk about an acid, so what is an acid? An acid is a compound which, when dissolved in water, then it produces hydrogen ions as the only positive ion. For example, sulfuric acid over here produces 2 hydrogen ions. Hydrochloric acid produces 1 hydrogen ion. Carbonic acid produces 2 hydrogen ions. Sulfurous acid produces 2 hydrogen ions. Nitric acid produces 1 hydrogen ion, and phosphoric acid produces 3 hydrogen ions respectively. So all these acids will produce hydrogen ions when dissolved in water. Hence, they are known as acid. So what is an acid once more? An acid is a compound which when dissolved in water produces hydrogen ions as the only positive ion. And as far as negative ions are concerned, there are different negative ions in each of the acids. Over here in sulfuric acid we have SO4 2 minus. In hydrochloric acid we have Cl minus. In carbonic acid we have CO3 2 minus and SO3 2 minus. Nitric acid has NO3 minus and PO4 3 minus. So negative ions are different in different acids, but the positive ions are all hydrogen ions, which are positive. So what is an acid once more? An acid is a compound which when dissolved in water produces hydrogen ion as the only positive ion. Is it okay? Now, in the books it says hydrogen or hydronium ion, H3O+. So actually we talk about this in the next chapter, chemical bonding, but I'll give you just a little bit of an idea how H3O plus hydronium ion come into existence. So water, when it combines with the hydrogen ions, in fact when hydrogen ions combine with water, it produces hydronium ions, H3O plus. Is it okay? So we can call it hydrogen ion or hydronium ion. Hydronium ion comes into existence when the hydrogen ions comes into combination with water and forms H3O plus. That's all over here, you have to remember. We'll do that in detail in the next chapter. So now, since we are talking about acids, there are many types of acids, different types of acids. On the basis of sources of acid, I already told you, one is organic acid and the other is mineral acids. All these sulfuric acid, hydrochloric acid, carbonic acid, sulfurous acid, nitric acid and phosphoric acid, they are mineral acid. They are derived from minerals. Okay? But organic acids are derived from plants, especially plants. You know, citric acid, which is found in citrus fruits like lemon, oranges, oxalic acid, tartaric acid in tamarind, acetic acid. You must have heard about acetic acid, vinegar. That's a organic acid. Number two, we come to the classification of acid on the basis of molecular composition of acids. We call it hydroacid, number one, and the other is oxyacid. So hydroacid, as the name implies, it has hydrogen and a non-metallic element other than oxygen. It does not have oxygen in it. These are called hydroacid. Over here, HCl does not have oxygen in it, so therefore HCl is a hydroacid. Okay. Similarly, we have HF, hydrofluoric acid, HBr, hydrobromic acid, HI, hydroiodic acid. So these are, and HCl, it does not contain hydrogen, so it does not contain oxygen, so therefore it is known as hydroacid. Now when we talk about oxyacid, oxyacids are those acids which contain hydrogen, any other non-metallic atom, as well as oxygen. So those acids which contain oxygen are known as oxyacid. Is it okay? For example, we have sulfuric acid, carbonic acid, sulfurous acid, nitric acid and phosphoric acid. They contain oxygen, so therefore they are known as oxyacid. Now, let us talk about the strength of an acid. You must have heard about a strong acid, a weak acid. Okay? Now, what does it mean? Now, what does the strength of an acid depend upon? Okay? What does the strength of an acid depend upon? The strength of an acid depends upon the concentration of hydrogen ions present in the solution of an acid. Okay, so it is the strong acid and weak acid depends upon the concentration of hydrogen ions. The concentration of hydrogen ions or the hydronium ions. That depends. So, the strength of an acid. Strength, strong or weak acid. Strong or weak. The strength of an acid depends upon the concentration of hydrogen ions, or we can say in a solution hydronium ions. So if an acid dissociates almost completely, almost completely to produce high concentration of hydrogen or hydronium ions, we call it a strong acid. Okay. For example, here when we talk about the strong acid, let us talk about HCl, one of the strong acid. HCl dissociates into H plus and Cl minus ions. Okay, hydrochloric acid dissociates into hydrogen ions and chloride ions. So, since in this acid, hydrochloric acid, hydrogen ions are dissociates completely to produce very high concentration of hydrogen ions. Therefore, it is called a strong acid. So, I repeat once more, a strong acid is an acid which dissociates almost completely to produce high concentration of hydrogen or hydronium ions. Therefore, it is called strong acid. Similarly, nitric acid, HNO3, dissociates completely to produce high concentration of hydrogen ions and nitrate ions. Now over here, the valency is very, very important. I've told you to learn it in class 7. That is why. Because over here, hydrogen, as you all know, the valency of hydrogen is 1. Therefore, it produces a single positively charged ion. Chlorine, the valency is 1. So therefore, it produces negative ions. One negative ion. A negative ion with a single negative charge. Similarly, nitrate valency is 1. So therefore, it produces an ion with a single negative charge, because the valency is 1, it has only one negative charge. Alright? Over here, now we come to sulfur. Let's talk about sulfuric acid, another strong acid. Now, sulfuric acid is also another strong acid which dissociates to produce. Now, please understand this. Since there are two atoms of hydrogen, H2, okay, there are two atoms of hydrogen, it produces two ions of hydrogen with a single positive charge. Why is it single positive charge? Because the valency of hydrogen is 1. So therefore it produces a single positively charged particle, an ion. And since there are two atoms of hydrogen in the sulfuric acid, since there are two hydrogen ions in the sulfuric acid, it produces two hydrogen ions. Okay? And sulfate ions, since the valency of sulfate is 2, SO4, valency is 2, it has two negative charges. SO4, 2 minus. Okay? Understood? Now, when we talk about nitric acid, H3PO4. H3PO4, now hydrogen. It obviously the valency is 1. So therefore it produces a single positive charge. Okay? Hydrogen, a single positive charge. Ammonia, hydrogen, and all the metals without any exception has positive charges, will produce positively charged ion. I repeat, hydrogen, all the metals without any exception, and ammonium, NH4. When we talk about ammonium, it is NH4 ion, it is NH4 plus. Please, I have told you repeatedly earlier also, ammonium, hydrogen and metals, they form positive ions. So anyway here, so hydrogen, positive charge. Because its valency is 1, it produces a single charge. It has a single positive charge. Now, how many atoms are there in hydrogen over here? How many in sulfuric acid? How many atoms of hydrogen? There are 3 atoms of hydrogen in sulfuric acid, phosphoric acid. So therefore, it produces 3 ions of hydrogen having a single positive charge. I want to repeat it. Why is it H plus only 1 single positive charge? Because hydrogen's valency is 1, so therefore it has a single positive charge. And how many atoms are here over here in phosphoric acid? There are 3 atoms of hydrogen in the phosphoric acid, so therefore it produces 3 ions of hydrogen. Is it okay? It dissociates to produce 3 hydrogen ions per molecule of the acid. And now phosphate, PO4. Now, phosphate, obviously, it's not a metal. It's not a metallic radical. So therefore, it will produce a negative. It forms a negative ion. Now, how many negative ions? How many negative charges does it have? It depends upon the valency. For valency of phosphate, PO4 is 3. So therefore, 3 minus. Is it understood? All right. So now, this is all about dissociation, strength of an acid. So I repeat, the strength of an acid depends upon the concentration of hydrogen ion it produces in its aqueous solution. If an acid produces high concentration of hydrogen ions in its aqueous solution, then it is called a strong acid. For example, most of the mineral acid, I'm not saying all, I'm saying most of the mineral acids are strong acids. Like for example, sulfuric acid, hydrochloric acid, carbonic acid, sulfurous acid, nitric acid and phosphoric acid. They are mineral acids. Okay? But this is sulfuric. Now over here, carbonic acid. Carbonic acid is a weak acid. Rest of them are all strong acids. So mineral acids usually are strong acids except carbonic acid. Carbonic acid is a weak acid. I'll tell you why. Okay? Now, when we talk about weak acid, what is a weak acid? Weak acids are those. Again, the strength of an acid depends upon the concentration, isn't it? So, concentration of what? Concentration of hydrogen ions in its aqueous solution. Aqueous solution means when the acid is added to water. When an acid is added to water, it produces hydrogen ions. Obviously, since it is an acid, it produces hydrogen ions as the only positive ion. So, since an acid produces low concentration, it produces low concentration of hydrogen ions in the solution. Therefore, we call these type of acids as weak acid. So, what is a weak acid? A weak acid is an acid which dissociates partially. Which dissociates partially to produce low concentration of hydronium ions or hydrogen ions in its aqueous solution. Therefore, we call these acids as a weak acid. For example, all the organic acids, tartaric acid, malic acid, citric acid, acetic acid, these are all organic acids, and organic acids are weak acids, very, very weak acids. Even though they are acids, but they are very, very weak acid. Why are they weak acid? Again, I want to repeat it for the last time, that it dissociates to produce low concentration of hydrogen ions in its aqueous solution. Is it understood now? Okay. Now we talk about, I forgot to tell you, what about the mineral acid? Which is the weak mineral acid? As I already told you, carbonic acid, H2CO3. H2CO3. How do we get H2CO3? I will tell you. So when we talk about carbonic acid, this is it. Now, when carbon dioxide, which is in the air, okay, it dissolves in water. Carbon dioxide is sparingly soluble in water. It's not highly soluble in water. We have to force carbon dioxide under high pressure to dissolve in water. It usually doesn't. Okay? So it forms carbonic acid, H2CO3, which is a weak mineral acid. It is a weak mineral acid. Carbonic acid is a weak mineral acid. Okay? Now, why is it a weak mineral acid? Because if there are let's say, if there are thousand hydrogen molecules of carbonic acid in water, okay? Let me make it clear. It dissociates into, okay, how many atoms of hydrogen are there? 2 atoms. So there will be 2 hydrogen ions with a single positive charge, as we all know. And now carbonate plus carbonate is a non-metallic radical, so therefore it forms a negative ion. So what is the valency of carbonate? 2. So therefore 2 minus. How many carbonate radical are there? Only 1. So 1 CO3, 2 minus. So out of 100 molecules of carbonic acid in water, let's say 10 of them, 10 hydrogen ions dissociates. So therefore we call it a weak acid. So what is a weak acid? A weak acid is an acid which dissociates partially in its aqueous solution to produce low concentration of hydrogen ions. Therefore it is a weak acid. Now on the basis of concentration, now when we talk about the concentration of the acid now, okay? When we talk about the concentration of the acid, there is a concentrated acid and there is a dilute acid. Okay? What is a concentrated acid? A concentrated, don't get confused between strong acid and a concentrated acid. Okay? If in an acid the concentration of water is low and the percentage of acid is more, water is low, acid is more, then it is termed as concentrated acid. Okay? If in a solution the percentage of acid is more than the percentage of water, then it is called a concentrated acid. Okay? Now, when we talk about dilute acids are those in which the concentration or the amount of water or the percentage of water is more than the acid. Then we call it a dilute acid. Okay? So please do not get confused between strong acid and concentrated acid. Concentrated acid is an acid in which the concentration of acid is more than water, means the percentage of acid is more than the water. Whereas strong acids are those which dissociates completely to produce high concentration of hydrogen ions in its aqueous solution. Alright? Now, last topic we will deal is monobasic, dibasic and tribasic acid, the basicity of acid. Okay, we call it basicity of acid, B-A-S-I-C-I-T-Y, basicity of an acid. Basicity of acid. So when we talk about the basicity of an acid, what is it? Alright, it is the number of hydrogen ions which can be produced per molecule of the acid. It is the number of hydrogen ions produced per molecule of the acid, that is basicity of an acid. So now you will understand. Basicity of an acid is the number of hydrogen ions, H plus ions, per molecule of the acid. Okay, you know any acid, for example, HCl, whether it dissociates completely or whether it dissociates partially, whether it's a strong acid or a weak acid, does not matter, it will dissociate. So HCl dissociates to produce how many atoms of hydrogen here? 1. So therefore it will produce only 1 hydrogen ion. And how many atoms of chloride here? 1. So therefore it will produce only 1 Cl minus. So HCl dissociates into H plus and Cl minus. Next, HNO3. Nitric acid dissociates to produce only 1 hydrogen ion per molecule of the acid, H plus and Cl minus. NO3 minus. Okay, so since it has only 1 molecule of hydrogen here, it has only 1 molecule of hydrogen in the acid, in hydrochloric acid and nitric acid as well. So therefore, it produces only 1 hydrogen. Similarly, we have hydrofluoric acid, HF, again produces only 1 hydrogen ion per molecule of the acid and F minus, because the valency of fluorine is at 1. So therefore, since it's a non-metal, so therefore it will produce negative ion. Next, hydroiodic acid, HI. So it will again produce only 1 hydrogen ion and then 1 iodide ion. Similarly, hydrobromic acid, HBr. It produces 1 hydrogen ion of the acid and Br minus. So in all the cases, hydrochloric acid, it produces 1 hydrogen ion. Nitric acid, it produces 1 hydrogen ion. Hydrofluoric acid produces 1 hydrogen ion. Hydroiodic acid produces 1 hydrogen ion. Hydrobromic acid produces 1 hydrogen ion. In this case, it all produces only 1 hydrogen ion per molecule of each of the acid. So therefore, they are called mono. They are known as monobasic acid. Mono means over here 1. Monobasic acid. Hence, we call it monobasic acid because it produces 1 hydrogen per molecule of the acid. Now, we talk about dibasic acid. Okay? Now we talk about dibasic acid. Now, what is dibasic acid? Dibasic acid. What is dibasic acid? Now, dibasic acids are those acids which dissociates whether partially or completely, it doesn't matter. Okay? We are not talking about the strength of an acid here. Right? So, dibasic acids are those which ionize in the solution, which dissociates to produce 2 hydrogen ions per molecule of the acid. Okay? 2 hydrogen ions per molecule of the acid. Then, for example, H2CO3, H2SO4, H2SO3, and so on. Okay, we'll take 3 samples here. Carbonic acid, sulfuric acid, sulfurous acid. We are not talking here about the strength of an acid. We are talking about they are dibasic acid. They are dibasic acid. Why are they dibasic acid? Because they produce 2 hydrogen ions. Now, why 2 hydrogen ions? Because in the acid there are 2 hydrogen atoms combining with 1 molecule of carbonate. So therefore, it produces 2 hydrogen ions, 2 H plus. Getting my point? Since it has 2 hydrogen atoms in the molecule of carbonic acid, therefore it produces 2 hydrogen ions. Okay? Now, and of course, hydrogen ions is done. Now we talk about carbonate ions. Obviously, it is a non-metallic radical, so therefore it produces negative ion. Okay? Now, how many negative ions? Only 1, because there is only one carbonate radical here, so therefore it will produce only one carbonate ion. Now what is the valency of carbonate? 2, so therefore it produces 2 minus. So each carbonate ion will have 2 negative charges. Okay. So what is a dibasic acid? Dibasic acids are those acids which produces 2 hydrogen ions per molecule of the acid. Similarly, this is very, very important. You have to understand this. Now, sulfuric acid. Sulfuric acid is dissociated in its aqueous solution to produce, obviously, hydrogen ions. But how many hydrogen ions? It depends upon how many atoms of hydrogen are there in the acid, in one molecule of the acid. So, since there are 2 atoms of hydrogen, so it will produce 2 ions of hydrogen. And over here, sulfate. Hydrogen is done. Now we come to sulfate ions, SO4. Now, since it is a non-metallic radical, so therefore it produces negative ions. Okay? Non-metallic are negative, except for hydrogen and ammonium. Hydrogen and ammonium. Hydrogen ions and ammonium ions are positive, and all the metals, they are positive ions. Whereas other acids, other radicals, they produce negative ions. So sulfate, since it is a non-metallic radical, so therefore it produces negative ions. Now how many negative ions? 2. Why? Because the valency of sulfate is 2. Alright? Now next, we come to sulfurous acid. So sulfurous acid, when we talk about sulfurous acid, it's again, how many atoms of hydrogen are there in one molecule of sulfurous acid? There are 2. So therefore it produces 2 ions of hydrogen. Why H plus? Because the valency is 1. Why 2? Because there are 2 atoms of hydrogen here. Now next is, it produces sulfite, SO3. Again the valency is 2. And since it is non-metallic, it produces negative charge. So these are some of the dibasic acid. Now we talk about tribasic acid, okay? Now tribasic acid. Tribasic acids are those which produce 3, as the name implies. Mono means 1, di means 2, tri means 3. So therefore, tribasic acid. Tribasic acid. So tribasic acids are those which produces 3 ions of hydrogen per molecule of the acid. So we'll talk about only one acid, that is phosphoric acid, H3PO4. Now it is dissociating in its aqueous solution. Now how many atoms of hydrogen are there in one molecule of phosphoric acid? There are 3 atoms of hydrogen. So therefore it will produce 3 ions of hydrogen. Now why only 1 plus? Because valency is 1. Valency of hydrogen is 1, so therefore 1 plus. Why 3 ions of hydrogen? Because there are 3 atoms of hydrogen here. Getting the point? Now next is 3H plus and PO4 ions. Now PO4, obviously it is not a metallic radical, so therefore it forms negative ions. And what is the valency of phosphate? 3, so therefore 3 minus. So this is 1 PO4 3 minus means 1 ion of phosphate having 3 negative charges. Getting my point? Next, I repeat it once more. PO4 3 minus means 1 ion of phosphate, 1 phosphate ion having 3 negative charges. Over here, a 3H plus over here means 3 ions of hydrogen having only 1 positive charge each. There are 3 H, like 3H plus means H plus, and H plus. 3 ions of hydrogen having a single positive charge. Why single positive charge? Because the valency of hydrogen is 1. So the number of charges, the number of charges depends upon the valency. That's why I told you all to learn the valency properly. Okay. In the next class, we will talk about bases. we will talk about the bases. For now, thank you very much.